Welcome back to another day of advanced algebra. Today is day 3. We are taking notes on section 6.2, which is dividing polynomials. Before today, we added, we subtracted, and we multiplied polynomials. Today we're going to divide using long division. Tomorrow we're going to divide using synthetic division. Today's lesson might be a little confusing at first, so please make sure that you pause the video and go back if you need to. So first, a look at the two different types of dividing we're going to be doing. First, we're going to divide polynomials by monomials, and then we're going to divide polynomials by polynomials using long division. So first example is dividing a polynomial by a monomial. There's two steps. The first step is to separate the polynomial in the numerator into monomials. The second one is to simplify each fraction. Please make sure you have both of those written down. Okay, so first thing, separate the polynomial in the numerator into monomials. Here's our first monomial, here's our second one, here's our third one. I'm going to write these as three separate fractions. So I have 6x to the fourth, y to the third, over 3xy squared. To that, I'm going to add 12x to the third, y squared, all over 3xy squared. And lastly, I'm going to subtract 18x squared y, all over 3xy squared. Okay, that was the first step. Second step, simplify each fraction. 6 divided by 3 is 2. Then I have x to the fourth over x to the first, which is x to the third, because remember you want to subtract the exponents. And then I have y to the first, because 3 subtract 2 is 1. Next, 12 divided by 3 is 4, so I'm going to add 4. X to the second, because I'm going to do 3 subtract 1. And then y to the second over y to the second is y to the 0, which is just 1. Lastly, 18 divided by 3 is 6. X to the second over x to the first is just x to the first, because I want to subtract the exponents. Then I have y to the negative first, because I want to do 1 subtract 2. Okay, I'm not finished yet. I'm not allowed to leave this y to the negative first. We never leave negative exponents. So I'm going to rewrite. This is 2x to the third y. I'm adding 4x squared. Remember, y to the 0 is just 1, so I don't really need to write that. And then I'm going to subtract 6x all over y. Remember that for a negative exponent, I want to move, in this case from numerator to denominator. This is my final answer. Okay, here's two examples for you to try on your own. Please pause the video, try both, and then come back. Okay, hopefully you had a chance to try both of these on your own. First thing that you should have done is separate the numerator into monomials. Next thing, you should have simplified each fraction. 20 divided by 4 is 5. I have c squared, because 4 subtract 2 is 2. D. Those f's, there's one in the numerator and one in the denominator, they just divide to be 1. And then I'm going to subtract 4. C to the negative first, because 1 subtract 2 is negative 1. Again, 1d in the numerator, 1 in the denominator, they divide to be 1. And then I have f to the first power. Not allowed to leave negative exponents. I'm going to rewrite this first monomial. I'm going to subtract 4f all over c. C is the only variable that had negative exponents, so that's the only one that moves. The 4f stays in the numerator. Okay, second one. This looks a little bit different than what we've been doing because of this part. Remember that a negative exponent just means put it in the denominator. So first thing I'm going to do is rewrite this so that it looks how we have been doing these problems. Okay, now this looks like what we've been doing. We're taking a polynomial, dividing it by a monomial. So I'm going to separate that polynomial in the numerator into two monomials. I have 18a squared b all over 3ab. I want to add 27a to the third b squared c all over 3ab. My last step is to simplify both of those fractions. 18 divided by 3 is 6. A squared over A is A. There's one B in the numerator, one B in the denominator. They divide to be 1, so I don't even need to write B. Now I'm going to add. 27 divided by 3 is 9. A to the third over A is A squared because I want to subtract. And then I have B, C. That's my final answer. Okay, so that was dividing a polynomial by a monomial. Now we're going to divide polynomials using log division. Before we do that, I have a quick break for you. What is America's first and oldest hamburger chain? My hint for you, it is still around today, this chain. You've definitely heard of it. So, see if while we're going through the next few problems, you can think of an answer for this. Okay, so I told you today we're going to be using log division. Most of you probably learned log division back in elementary school, but I'm going to guess you probably don't remember. So before we even jump into polynomials, we're going to do a few log division problems using just numbers. I want to divide 216 by 12. So first thing, 216 goes in the box. 12 goes outside the box. Okay, how many times does 12 go into 2? It goes in 0 times. Now what's 21 divided by 12? 12 goes in once. Okay. 1 multiplied by 12 is 12. And now I want to subtract. 21 subtract 12 is 9. And then bring down your 6. Okay, now what's 96 divided by 12? That's 18. Now I want to multiply again. 8 multiplied by 12 is 96. And I want to subtract. 96 subtract 96 is 0. This is our remainder. So what that just means is 216 divides evenly by 12. So 216 divided by 12 is 18. Okay, most of the time your remainder is not going to be 0. You're actually going to get a number for your remainder. So our next example is one where we do have a remainder that's not 0. This time I want to divide 233 by 11. So first thing, 233 goes in the box. 11 goes outside. Okay, 11 does not go into 2 evenly, but it does go into 23. 11 goes into 23 2 times. 2 multiplied by 11 is 22, and now I want to subtract. 23 subtract 22 is 1. Bring down the 3. Okay, now how many times does 11 go into 13? It goes in 1 time. I want to multiply. 1 multiplied by 11 is 11, and subtract. 13 subtract 11 is 2. Now, does 11 go into 2? No. We have nothing to bring down, so this is our remainder. Okay, so we say 233 divided by 11 is 21 with a remainder of 2. We don't generally write it like this, though. Instead, we write 21, and then that 2 we couldn't divide by 11, so we just leave it as 2 over 11. So this was a quick review of long division. Hopefully that jogged your memory. Now we're going to divide polynomials using long division. So first thing, that x squared add 3x subtract 41 goes in the box. X subtract 5 goes outside the box. Inside the box, you have to go in decreasing order of exponents. So here we have x squared, x, and then our constant. Always has to be decreasing. Okay, first thing, x squared divided by x is just x. Now I want to multiply. X multiplied by x is x squared. X multiplied by negative 5 is negative 5x. Now if you remember from before, we want to subtract. X squared subtract x squared is 0. This should always happen. 3x subtract negative 5x is positive 8x. Please remember that you are subtracting. Now I want to bring down the negative 41. Now I want to divide again. 8x divided by x is just positive 8. Now multiply. 8 multiplied by x is 8x. 8 multiplied by negative 5 is negative 40. And remember that you want to subtract now. 8x subtract 8 subtract 8x is 0. Remember from up here, we got a 0, so we know we're on the right track. Negative 41, subtract negative 40 is negative 1. So remember, we're subtracting. I can't divide negative 1 by x, so this is the remainder. So I say my answer is x add 8 with a remainder of negative 1. Remember, we don't generally leave that remainder like that. So this is x add 8. Our remainder is negative 1, and we couldn't divide that by x subtract 5. So this is my final answer. I know this is a little confusing, so we're going to do one more together, and then you're going to do one on your own. Okay, here's the one that we're going to do together. Remember that all this to the negative 1 just means that we're dividing by that. So the 2x add 6 goes outside the box. Inside the box, I have 4x to the third, add 8x squared, add 0x, subtract 6. Okay, so this is a little different than the last example. The last example had an x squared, x, and a constant. You always have to go in decreasing order. So even though we don't have an x term, we still need to put a 0x kind of as a placeholder. Okay, so let's start our division. 4x to the third divided by 2x. 4 divided by 2 is 2. X to the third divided by x is x squared. Now I want to multiply. 2x squared multiplied by 2x is 4x to the third. 2x squared multiplied by 6 is positive 12x squared. Now I want to subtract. 4x to the third, subtract 4x to the third is 0. Remember, I should always get 0, so that's how I know I'm on the right track. 8x squared, subtract 12x squared is negative 4x squared. And I want to bring down that 0x. Okay, now I want to do negative 4x squared divided by 2x. Negative 4 divided by 2 is negative 2. X squared divided by x is x. Now multiply. Negative 2x multiplied by 2x is negative 4x squared. Negative 2x multiplied by 6 is negative 12x. And now I want to subtract. Negative 4x squared, subtract negative 4x squared is 0. Again, I'm on the right track. 0x subtract negative 12x is positive 12x. Remember that we're subtracting. 0 subtract negative 12, positive 12x. And bring down that negative 6. Okay, now I have 12x divided by 2x. 12 divided by 2 is 6. Now I want to multiply. I'm going to continue this up here so I don't run out of room. Okay, 6 multiplied by 2x is 12x. 6 multiplied by 6 is positive 36. And now I want to subtract. 12x subtract 12x is 0. Again, I'm on the right track. I should always get that 0. Negative 6 subtract 36 is negative 42. Can't divide negative 42 by 2x, so this is my remainder. So my answer is 2x squared, subtract 2x, add 6, with a remainder of negative 42. Remember, we don't generally write it like that. Instead, I'm going to write 2x squared, subtract 2x, add 6. My remainder is negative 42 when I was dividing by 2x, add 6. So that's my final answer. Okay, here's the one for you to try on your own. Pause the video. If you don't know what to do, go back and re-watch me complete one of the first 2 problems. See if you can figure it out. Come back after you've completed this problem. Okay, First thing that you should have done is put 4x to the third, subtract 2x squared, subtract 7x, add 6 in the box, x minus 1 goes outside. 4x to the third divided by x is 4x squared. Now I want to multiply. I get 4x to the third, subtract 4x squared, subtract 4x to the third, subtract 4x to the third is 0. Negative 2x squared, subtract negative 4x squared becomes positive 2x squared. 2x squared divided by x is 2x. Sorry, I'm having a little technical difficulties. Okay, 2x, multiplying, I get 2x squared, subtract 2x. Sorry, I forgot to bring down that negative 7x. Now subtract 2x squared is 0. Negative 7x, subtract negative 2x becomes negative 5x. Bring down that 6. Negative 5x divided by x is negative 5. Sorry, I ran out of room again. Okay, multiplying. Negative 5 multiplied by x is negative 5x. Negative 5 multiplied by negative 1 is positive 5. And now I want to subtract. Negative 5x subtract negative 5x is 0. 6 subtract 5 is 1. That's my remainder. So your answer should be 4x squared, add 2x, subtract 5. My remainder is 1 over x minus 1. So that's the final answer. Okay, so just to look back at what we did today, we divided polynomials by monomials. We separated the numerator into monomials and then simplified each fraction. And then we divided polynomials using long division. So what is America's first and oldest hamburger chain? The answer is not McDonald's. White Castle. So again, you're going to come to class, we're going to do some problems on long division, and then we'll do synthetic division next. Thank you, and bye.